Hello and welcome to another video question and answer time with containerhome.info. In today's question, Mark Tolman asks, I have a question about the future portability of a finished and modified container home. With a 8 to 10 foot cut in the sides and the doors removed at one end for glazing from a 40-foot high cube container. Will the tensile strength of the container still stand up to being relifted, and will tiled floor finishes, etc., remain intact? Very good question, Mark. So as always with these question answer times, I'm going to answer your question in a broader sense, hopefully to provide value not just to yourself but to other people that are watching this material. So let's start with an understanding that whenever you talk about modular construction technology, regardless of whether we're talking about container-based modular construction or traditional lumber-built modular construction, it's important to understand that the greatest stresses that building envelope are going to be subjected to aren't actually going to be a result of the prevailing climatic conditions, in other words, where the house is built. The greatest stresses that building envelope are going to be subject to is at the moment when that building module is lifted into place. The forces that are involved on that building module at that time are significant. And when I say significant, I mean significantly more than they're ever going to be subject to as a building envelope. And so what we need to understand is that creating a structure that's capable of being exposed to those stresses and doing well isn't something that just happens. The design of modular buildings with specific focus on meeting those needs is very much an art form. It's very much a skill. And as I said, that's true in traditional lumber-built modular housing, and it's also true in container-based modular construction. So the first thing I would like to suggest is that yes, it is absolutely 100% possible and practical, and I'm going to show you a couple examples, to design and build container-based construction projects with an eye on future relocation, 100%. But we have to be practical in understanding that just because it's built from a container doesn't mean that we can ignore the laws of physics here. So what that means is that as we go through some of these examples, you'll see that progressively, as the structure of the container is degraded, as the structural integrity of the container is degraded, as we modify the container more and more and more, we're going to introduce greater and greater list of problems that need to be addressed in this process. So let's start off with the easy marker, as it were. So this is traditionally where container-based construction gained its reputation for relocation capability. With the mining industry, with hunting cabins, and originally and most predominantly with research stations and with the military. And when you're looking at a container like this, you can see there's really isn't a great deal of modification on this container. We have relatively small openings in the sidewalls. We're retaining the end doors on the container so that we can close them up, and that provides us some structural rigidity when we move, a small degree. Moving a container like this and designing a container like this so it can be moved is a relatively straightforward task. It's really just common sense. What happens is as we progress, as we move away from this kind of concept more into what I would call a container home. So we're not talking about an accommodation project, but a container home. The complexities of that task grow. So this is a great example of what I think of a home that is relocation capable. It's designed to basically at some point in the future to be able to be moved if you needed to move it. But again, what you'll notice, some of the maybe not so obvious features of this home is that as you look through the windows and the doors and the openings of this container, is We're not talking about removing the entire sidewall of a 40-foot container and replacing it with glass and then claiming that we're going to be able to pick this thing up with a crane and move it at some later point in time. It's designed with an intent of exposing this building in its modules to those expected stresses. So there's a design methodology, there's a thought process going into that. I want to compare that to this particular building here. Now, this building is interesting because it was a temporary structure, and so by nature you would kind of consider it to be relocatable. It was designed and built for a housing expo. But if you actually look at this particular building, you can see the amount of structural modification that we've put on this container is significant. Entire sidewalls of the lower container have been removed, significant portions of glazing in the upper container. The difference between these three structures, this one here, this one here, and this one here, quite frankly, are profound in terms of its relocation capability. One of them, you could literally pretty much at any point in time pull up with a side loader or some type of truck that's capable of carrying this container, lift the thing off its foundations, put it on the truck and drive away, and pretty much do that as often as you want. You're really not going to subject this container to stresses that are going to be highly problematic. The second project requires a little bit more thought, a little bit more planning. It's not something you can kind of just drive away with, but it's certainly what I would consider to be relocation capable. And the third project starts to become problematic, where we're basically looking at how do we manage the stresses without damaging the building envelope. And at the same time, what we need to consider when we're talking about these discussions is the external elements of the building and the internal elements. So let me give you an example. If you were to, for example, remove the modest sections of the sidewall and replace them with some degree of doors and glazing, and then frame out the building and use a material, say plywood, and then cover the plywood with a laminate or some type of vinyl material, all of these materials are going to be good choices for relocation capability. At the opposite end of the spectrum, if we have large areas of glazing and we're talking about using floor tiles, where basically we're grouting the floor tiles and things like this, these are two very different material selections that lend themselves very differently to the project. So the answer to your question, Mark, basically is this: are container-based structures relocation capable? And the answer is 100%. Absolutely. They've proven themselves to be a tremendous asset to the military, to the mining industry, to the hunting cabins industry. There's a huge number of successful projects and successful companies that utilize these technology for relocation capable projects. It's very well understood. It's very strong. There is, however, a limit. And that limit is going to be specific project to project, and it's going to be specific to material selection and design applications, and just a whole bunch of individualized discussions that have to happen around your project. So what I'm going to suggest here is, this is, like all of these question and answer, a fairly high level overview of what we're talking about here. And then we need to drill down into your particular project and your particular needs. And if you're interested, I'm more than happy to help you walk through how we can best design a container project. And as you've already said, an 8 to 10 foot opening, the material selections, how we'll structurally reinforce that, specifically for your needs, specifically for your project. So as always, there's high level general recommendations that we can make globally. And then there's going to be the need to look at the individual project. And this is just always going to be true. It's just a reality of the business that we're in. So I hope that at least helps. Yes, certainly possible. Comes down to structural reinforcement of the container. It comes down to how you're going to move the container, what equipment you've got access to. It comes down to the material selection. There's very definitely materials that are better suited to that task than others. And at the end of the day, it's very much project by project specific. I hope that helps, Mark. Great question. Thank you very much for your time. And I look forward to seeing you at the next question and answer